We're going to look at statistical tables and graphs and also graphics in the media. So before we get started, I wanted you to take a look at this picture here, which actually are two different graphical displays, and just take a few minutes to write down what you notice about it and what story do you think the graph is depicting. So in this graph, you can see that we have years on the horizontal axis, which is your x-axis. And then we have age of victim, which is on the vertical axis. So the y-axis, the up and down axis. And this type of graph with all these dots is called a scatter plot. Scatter plots are used when you have two quantitative variables. So we're going to talk about quantitative variables shortly. Quantitative variables are variables that are numbers with units. Examples could be like weight or height. If you were to count things, that could be quantitative. And then we also have these bars here. It looks like a bar graph, but actually it's a type of histogram, which also records counts of quantitative data. It shows frequencies. So one of the things that you might notice is that most of the dots on the scatter plot are kind of clustered up here above 60, so 60 years. We also see that men are the open circles, women are the closed circles, and it appears that there's more women than men that were victims. And we can see also that there was a large percentage of killings that took place, or victims rather, that died here, from maybe the year 1993 all the way to about 1998 or so. And you can see in the histogram that it also represents that. So this is showing us here that, there was a large proportion of victims from during this time period here, so in these years. And we can also see that this histogram showing us like the number of victims that were a certain age. And we can see that the majority of these victims, again, are older, right? They're about 65, 60 or older. So this graph represents actually killings of a doctor. His name was Dr. Harold Shipman, and he lived in England and he practiced medicine, and he was killing his victims, and they tended to be women that were over the age of 60. He was giving all of his victims, men and women, large doses of opioids. Specifically, it was a type of opioid called diamorphine, which is used as like a painkiller. It's a very strong medication. But these victims were, calling Dr. Shipman to his house, or to their house, and he was coming to treat them, and he would give them, an overdose of this diamorphine. And it wasn't until he had one of his victims change their will, the families of that victim started to become very suspicious, and they looked into all of these deaths. And when they, looked at these graphs and they looked at the statistics behind it, they found that, there's a lot more here than they thought there would be. These are not just random people dying from old age, that there's a pattern and a trend, and that they were able to determine that he was murdering his victims. So he was a serial killer, at the time, and it was statistics really that solved or proved that he was doing these murders. Here you can see another graph. And this is a line graph. It's actually two of them. So we have like a double line graph, multiple line graph. You can see here it's percentage of deaths and then the hour that they occur, right? So from like midnight all the way, throughout the day, you can look at the comparison of other general practitioners. So when they record times of death for their patients, but then you look at Harold Shipman's, and clearly right here you can see that there's a huge spike. A lot of his victims were dying in the afternoon, early evening, more so than most other general practitioners. So that's something else that detectives, looked at when they were trying to prove that he was murdering these people. So, not everything is included in the graph, though. There are some things missing, like different patient characteristics that are not told in the graph. Like, did the patient have underlying diseases? Was it an accidental death, etc.? So, graphs don't tell us everything, but they can give us a starting point or give us some clues, and kind of direct us to a solution. Okay, let's take a look here at a type of table. It's called a frequency table. It's an organized list, if you will, of data. So, typically data is not organized for us when we collect it. When I say data, I just mean like information about things. So, if you go onto Amazon and you order, Amazon collects data about you, like your name, your birthday, your geographical location, maybe your shirt size, types of books you like to read. That's all data. So here, a teacher makes a list of grades that she gave her 25 students on an essay, right? This is data. It's information collected about her students. As you can see, it's not organized. So one way to organize it is to create a table called a frequency table. And this frequency table has the grades A through F, and then the frequency. And frequency, like think of the word, frequent. It just refers to counts. So what we do is we can count how many A's there are, right? So we can see we've got 1, 2, 3, 4. And that's where this 4 came from. And you can do that for each of the grade letters, right? So there should be 7 people that got a B, 9 that got a C, and so on. We can also convert counts to what are called relative frequency. So anytime you see the word relative, think of percentages. And all we're doing is taking the frequency and we're dividing by the total number of people, which is 25. So 4 divided by 25 would give us 0.16, which we know is 16%. 7 divided by 25 is 28%, and so on. And it should add up to 100%, right? We can also look at what's called cumulative frequency. So cumulative, remember, just means like, if you take a cumulative test, that means it includes everything prior to what you're learning now, including what you're learning now. So for a cumulative frequency, I would take each of these numbers, so start off with 4, and I'm going to add the numbers that come after it. So 4 plus 7 gives me 11. Then I would add 11 plus 9, which gives me 20. 20 plus 3, which gives me 23. 23 plus 2, which gives me 25. Okay, and these can tell us, information as well. So for instance, if I said to you, what's the frequency or how many students scored a C or better? Well, you know that it's 20 because it includes the 9 plus the 7 plus the 4. Or how many students scored worse than a C? You know that it's 25 minus 20, so 5 people, right? So the frequency column displays just the counts. And in this case, it's the counts of the number of students that, scored an A through an F on the test. So frequency is just counts or number of data values in each category. Okay, letter B. How was the relative frequency for each grade found? So again, anytime you see the word relative, just think of a percentage. We're just going to convert to percents. And all we did was we took the frequency and we divided by the frequency total. And we looked at also cumulative frequencies, and all we did there was we added each row total to the row below it. Now, for this class, you're not required to create these things, so you're not going to be required to create a table, but you do need to know how to interpret the table. So, and that's something we're going to work on. We're going to look at two types of data. Remember, data, again, is just information that's collected about something. Could be numbers, categories. So you have what's called qualitative data, and qualitative is also known as categorical data. It represents categories or qualities. Some examples of that could be like eye color, brown, green, blue, gender, male or female. It could also be political affiliation. Okay, colors in a pack of M&Ms, colors, that could also be qualitative. It's categories, and the data just kind of falls in each category. When you have qualitative data or categorical, you can create graphs such as bar graphs, pie charts, also known as circle graphs. You can look at segmented bar graphs and so on. Quantitative, think of quantity, that involves numbers, so it's counts, and we also include measurements in that because a measurement's a number. Okay, it's numbers with units. And an example could be like height, weight, number of siblings, grams of sugar, anything that's a number that has a label associated with it. So here we have a bar graph and a circle graph, okay, which again are used for qualitative data. How would you interpret these graphs? Pretend you're the teacher in the above example, reporting to your colleagues on test results from the last test. What would you tell them? So remember, these are essay grades. Okay, so how would you describe this? Take a minute, pause the video, and jot something down, and tell us, the big things that you see from this. So a big takeaway for the bar graph on the left is, something that stands out to me is that 36% of the students scored a C. Something else that would stand out to me is maybe I would want to know what percentage of students scored a C or higher. So to get that, I would just take my 36% plus 28% plus 16%. So if I add 36 and 28, I get 64 plus 16. So that tells me that 80% of students scored a C or better. Now, if I jump over to the circle graph, right, if you don't want to read the relative frequency from the bars, this is kind of what a circle graph is set up to do. So it makes it much easier to look at relative frequencies. So here it's easy for me to count 36 plus 28 plus 16. to easily get 80%. Something else that you might be able to talk about is like maybe which percentage of students failed. So you would have 20% failed. So the majority of students got passing essay scores. Here's another circle graph, and this time it represents the 2017-2018 cost for Texas residents to attend the University of Texas at Austin, which was $25,440. The circle graph shows the percentages of that cost for tuition, book supplies, room, board, and other expenses. Determine the cost in dollars for each category. Is this graph misleading? So, what I need to do is I need to figure out what percent of the whole would give me the amount paid for books, supplies, other room and board, and tuition, right? So I know that if you're paying $25,440, and let's say you're paying 3% of on supplies or books, so that's 3% of the 25,440. And we learned that 3% you would write as a decimal 0.03. Of means to multiply, so we're going to multiply that with the 25,440. And if I multiply 0.03 times 25,440, I get about $763.20. So out of the $25,440, you're paying about $763.20 for books and supplies. Okay, I'll leave the rest for you all to figure out. So you want to figure out how much is for room and board, tuition, and other. And the other thing you want to think about is this graph misleading at all? So I'll let you think about that. I won't get into that until we do the next video. Here's another problem that you can try on your own. And in this case, you have two other types of graphs. You've got a bar chart on the left, and you have what's called a time series graph on the right. Time series graphs just show how a quantitative variable changes over time, okay? Both of the graphs, when you look at them together, they just show the effect of COVID deaths on the US life expectancy by ethnic and racial groups between the years 2019 and 2021. So pause the video and look at the graphs, and you want to answer these questions. So what do you notice and what do you wonder? How does this relate to you and your community, and what is going on in this graph? Again, when we look at graphs, we're just trying to figure out how to tell a story, okay? So one of the things that should stand out to you here is the number of Native American people that died between the year 2019 and 2021. Even the number of Hispanic people, it was so much greater than some of the other ethnicities, right? I mean, look at Asian and white compared to, Native Americans and Hispanics. So there was a significantly worse outcome if you were Native American for both the cumulative COVID death rate, and then also if you look at the US life expectancy, look at the way the Native American life expectancy declines compared to the other ethnicities. So that's something that I would notice. How does this relate to you and your community? Maybe you're Native American, or maybe you have friends that are, or you live in a community where Native Americans or Hispanic people. This is something that would have affected you, or maybe still does affect you. Maybe you have relatives affected by it. what's going on in the graph, right? Well, I wonder, why were the death rates so high for Native Americans? And I know there's a large percentage of Native Americans that live in New Mexico. They live in like the Southwest, all over the United States. But I'm thinking of, specific groups in that area. And I know that sometimes there's a lot of poverty there. Maybe they don't have access to adequate health care systems. I imagine if you go to New Mexico and you're, in the middle of nowhere, there's probably not going to be a hospital around. And maybe they tend to live close together to each other, or they have large families that live in one house. I mean, all it takes is one person for COVID to spread, right? As we've learned. So it could be like a crowded home, that's multi-generational, like the grandparents, parents, and children all live there because they can't afford to live on their own. There's a lot of reasons that this could have been the case, but that's definitely something that stands out. So we're going to look at some other graphical displays. One of those is called a histogram. And a histogram is kind of like a bar graph, but the bars touch. So if you go back and you look at the bar graph here, notice that there's spaces between the bars. The reason is because bar graphs are used for categorical data. And if it's a category, it really doesn't have to be in order. I could take these bars and put them in a different order, and it wouldn't matter. Okay, now, in our brains, it makes a little less sense to switch them around because, we want to think of grades in terms of increasing to decreasing order, right? Or vice versa. But really, there's no law that says you can't switch them around. It would be like if I gave you a pack of Skittles and I said, make a graph that shows the color distribution. So you would just count the number of red, the number of orange, the number of yellow. You could plot that any way you wanted. You could put the orange first, and then the red second, and then the green third, and so on. So it wouldn't matter. But in a histogram, it does matter. So in histograms, the bars should always be touching unless there's just a space that appears naturally, if there's no data point that goes in a certain interval. So here we have a bar graph, and I put that in quotations because it's not a bar graph, right? It's a histogram, and it's used for quantitative data, so numbers with units, right? Where the bars touch. We place the observed values on the horizontal axis, right? So the one that goes left and right. And we place frequencies on the vertical axis. So the one that goes up and down. And histograms illustrate frequency distributions for quantitative variables. Okay, let's take a look at one. So here's a histogram, and it is displayed for televisions per home. So that's quantitative, right? Because it involves counts. I can count the number of televisions in homes. So it's a number. And notice that you have the number of televisions on the horizontal axis and then the number of homes on the vertical. So we're counting, how many homes have no television, how many homes have one television, and so on. So this is how you would read the histogram. The first question says, how many homes were included in the survey? Well, these represent the counts, the frequencies, right? So I would need to take each frequency and I would need to add it up. So here I would just have 2. So that tells me 2 homes have no television. And then the next bar is 4, and then 8, and so on. So I know 4 homes had 1 television, 8 homes had 2 televisions, and so on. So I'm just going to add all of the heights there of each bar. And we end up with 28. So there were 28 homes here that were included in the survey. How many homes were there 4 televisions observed? So I can see here that there's 4 televisions, right? How many homes had 4 televisions? 4. So I would look right here on the vertical axis. Okay, again, this is number of televisions, and then this is the number of homes. So there's 4 homes that had 4 televisions. When we're asked to find the modal class, right? I don't know if you've ever had statistics before, but we have the word mode. And the mode is the number that occurs the most, okay? So think of mode most. You can have more than one mode. You could have no modes. So if we're trying to find the number of televisions that occurred the most, on the graph, I would look for the peak. So my peak is the highest point on the histogram, and right here is my peak. So that tells me that there were 8 homes here, right, that had 2 televisions. So that's the one that occurred the most. So the modal class would be the 2. Now, how many televisions were observed? Okay, so here I have to do just some calculations. So there, right here we've got 2 homes had no TVs, right? So 2 homes times 0 TVs. Here I've got 4 homes had 1 TV. And what I'm going to end up doing is I'm going to add all these together, okay? Here I have 8 homes had 2 TVs, plus 6 homes had 3 TVs, and 4 homes had 4 TVs, 3 homes had 5 TVs, and last but not least, 1 home had 6 TVs. So here it would just be 0 plus 4 plus 16 plus 18 plus 16 plus 15 plus 6. So 4 plus 16 is 20, plus 18 is 38, plus 16 is 54, plus 15 is 69, plus 6 is 75. So there's 75 televisions that were observed. The next problem you can try on your own, and then you can unpause the video and move on to frequency polygons. So a frequency polygon is a line graph that is used to visually convey information you can use a histogram to construct a frequency polygon. And basically what you do is you draw a dot at the top of each rectangle at the midpoint. And then you connect with the straight lines. Both ends should touch the horizontal axis. So, if I was to go back here, Okay, what I'm going to do is I'm going to find the midpoint of each bar. So that's literally the middle of each of these. So I'm going to put a dot. Okay, these are your midpoints because they're in the middle of each bar. So I'm basically putting them above each of those numbers. And then you're going to connect with line segments. And then remember the last part that says you need to make sure that both ends touch the horizontal axis. So that means I need to come back down here, and I need to come back down here. So, again, frequency means counts, so we can easily look at this. If you were to remove the histogram, like pretend it was erased, you'd be left with this bar graph. We just call it a frequency polygon. And you can see the frequencies, right? It's in the middle. Like I can easily tell here that there were 8 homes that had 2 televisions. I can also see where it increases or where it decreases. In this instance, it's just telling me like, okay, it seems to be that 2 homes is the most, or 2 televisions is the most common. And after that, it seems that, less and less people have more and more TVs. In fact, there's only one person that was surveyed that had 6 TVs. So you can always, after you finished analyzing this histogram, you can try to create a frequency polygon for this histogram and see if you can figure out a way to interpret it. Here's some examples of other frequency polygons that we can use to answer some questions. So this is how you would interpret this. So this question, the frequency polygon is showing the number of email messages sent per day. So here you can see you've got the number of messages sent and then the number of people, right? How many people sent 5 email messages? Okay, so here's my number of messages sent, and I can see that I'm looking at 5 messages sent, and if I go up to the top, it shows me that there were 7 people that sent 5 messages. How many people sent 6 or fewer email messages? So here I've got 6, right? Messages sent, which is 4, but then also it says fewer. So it could also be 5 messages, 4 messages, or 3 messages, right? So I need to take this number 4 and add 7 and then 3 and 2. So if I add 4 plus 7 plus 3 plus 2, that leaves me with 16 people. So 16 people sent 6 or fewer email messages. How many people were included in this survey? So now I would need to add up all my frequencies. So I'm going to add 2 plus 3 plus 7 plus 4 plus 3 plus 8 plus, that looks like it's 6 plus 3. So 2 plus 3 plus 7 plus 4 plus 3 plus 8 plus 6 plus 3. And if I add that up, I get 36. So I know that 36 people were included in the survey. Now this next question says, construct a histogram from the frequency distribution. So now, this is where it's easy. If you have the frequency distribution, we're going to go backwards. So remember over here, we had the histogram and we constructed the frequency distribution. So now pretend this histogram wasn't there, right? If I have all these midpoints, all I have to do is just draw a bar around it and make sure the dot's in the middle for each of them. So in other words, I know that my bar is going to start at here, and I'm going to make sure that dot goes in the middle, right? So it's going to look something like this. And then I'm going to keep doing that and make sure that the dot goes in the middle. And that's it. You can pause the video and try the next check understanding. Again, it's a frequency polygon and you're using it to answer the questions. Okay, so we started easy with, just one bar graph. What if we have multiple bar graphs? So multiple bar graphs have two or more sets of bars that allow a comparison of two or more data sets. And we use this, of course, when the data is qualitative or categorical, right? So if I wanted to compare, let's say, for instance, like I have males and females, and maybe I want to look at eye color. So blue, green, brown, and maybe other. Okay, and then I've got males and females. So you would have like a bar that represents maybe number of males that have blue eyes, number of females, and then number that have green eyes for males, and then for females, and so on. Okay, and you would need some kind of legend, of course. So, maybe the yellow represents males, and then maybe green would represent females. Okay, something like that. Okay, and so on. So that's, one of the reasons we can use multiple bar graphs if we want to compare two or more qualitative data sets. So here's another example. We need to identify at least two general messages revealed by the graph below. Comment on how the use of the multiple bar graph makes these messages easy to see. So first of all, we want to look at the title, like what is this graph even showing us? And it's showing us the median annual earnings in 2019 of full-time workers ages 25 and up by educational attainment and gender. So in other words, right here, if someone was not a high school graduate, if they were a man, they made $37,148 median salary. So median means the middle number. So that means 50% of guys that didn't graduate high school made $37,148 or more, and then 50% made less than that. For women, you could say 50% of women made $26,471, or they made less than that. And it's showing each educational attainment. So you've got high school graduates, some college, no degree, and so on. And, one of the big things you can see here is that people that made the most money per year had some type of professional degree, okay? And you can also see that as the degrees increase, the median annual salary also increases, right? So, something we could say here is like the median annual earnings for men with a professional degree is approximately $150,095, compared to women, it was $102,455. So maybe we can subtract them instead of writing both numbers. And if you subtract those two numbers, you get what? 47,640. So the median annual earnings for men with a professional degree is about $48,000 more than a woman with a professional degree, right? So it is approximately, we'll say, 48,000 more than median annual salary for women. In fact, if you look at all of the bars, what does it look like to you if you compare men salaries to women's salaries? It looks like that regardless of the educational attainment, men have higher salaries than women. So just like we have multiple bar graphs, we also have multiple line charts. And we kind of looked at one earlier in the lesson when we looked at the data from Dr. Harold Shipman, right, and his victims, and they compared the number of deaths recorded by general practitioners over the course of a day versus the number of people that died on that were Dr. Howard Shipman's patients, and they noticed a very striking difference. So multiple line charts or line graphs, they're used for quantitative categories. And I'll put categories in quotations, right? Because it's not categorical data, but it's categories that have numbers. So, for instance, like year, number of deaths, and so on, right? So here we have US drug involved overdose deaths, all ages, from 1999 to 2019. And we have different types of drugs here. And we also have the number of deaths and the year. So, what type of drug was the leading cause of overdose deaths as of 2019? So as of 2019, if I look at the graph, right, I can easily see that synthetic opioids, so primarily fentanyl, was the leading cause of deaths in the United States. And I know this because it's higher than the other ones. I can also see that some of the other drugs, the number of deaths started to decline in 2019. So it looks like they were going down. Now, we don't know if they continued to decrease because we can't see anything after 2019. But we can see that some of these other ones did start to decrease. So we can see like prescription opioids started to decrease. We can even see that antidepressants kind of stayed flat, right? There was no change. We can see benzodiazepines started to decrease, but we can see that other ones started to increase, right? Like psychostimulants, so methamphetamines increased slightly. But here there was a sharp increase in synthetic opioids like fentanyl. What was the overall percentage change in overdose deaths that involved cocaine from 2010 to 2019. So if I'm looking for percent change, right? So we're doing the new value minus the old value divided by the old value. And this is for cocaine. So for cocaine, it appears that in 2019, it's about 15,900, 16,000. I know, for a fact it's 15,900. And then you can look at the old, so that would be in 2010, right? And again, we're looking at cocaine, which is the orange line. So the exact value is about 4,200. Now, if you're looking at the line graph, you can't tell that exactly, right? These would be rough approximations. Like, you could even say 16,000 minus 4,000. It would give you an approximate percent change. But I know from looking it up that it was 4,200. Okay, and I'm going to divide that by my old value. I'm comparing it to what it was before, right? So like, what's the difference compared to what it was? If I subtract 15,900 minus 4,200, I get 11,700. And I'm dividing that by 4,200. And then you also want to multiply by 100%, right? Because we're looking for a percent change. So 11,700 divided by 4,200. And then I'm going to take that number, 2.7857, multiply it by 100. So it's 278.57. It's basically about 280% change. So that's a huge change, right? As we go from 2010 to 2019. So over the course of 9 years, the percentage of deaths that involve cocaine increased by 280%. And you can clearly see here how the graph spikes upwards, right? From 2010, it gradually starts to go up, and then there's a sharp increase right here, and then it's gradually increasing again. But, that's very alarming. One other type of graph we're going to look at here are what are called geographical graphs. And geographical graphs are used to reveal geographical patterns in data. So here you can see agricultural yield of cereals in 2019 in tons per hectare. A hectare is similar to, I think it's around 2 acres. It's like 2.471 acres to be exact. So, they're talking about like how much cereal they're yielding per 2.471 acres. And the cereals they looked at were grains like wheat, rice, and corn. And they show, the whole world and how much they're producing. Okay. And then here you have another type of geographical representation. And here this is temperature. So here you can see widely separated contours mean large regions have nearly the same temperature. So you can see we call these contours, these areas here, and it's showing that those regions basically have the same temperature, just like these regions all pretty much have the same temperature, as do these regions. Closely packed contours mean a large temperature difference over a short distance. So what you're going to do is use those two graphs to answer the questions A and B. And that is pretty much it for this part of the lesson. Please come back for part 2 next week, and that will be on we'll be looking at misuses of statistics. So we'll be looking at graphs that may not be accurately created, or they can be interpreted in false ways, which we need to always be leery of and be aware of when we're looking at any types of graphs. Have a great day. If you have any questions, please reach out.